So we're going to quickly do an example talking about Jamestown Steel Company manufacturing and assembling desks and office equipments. They have a weekly production that follows a normal distribution with a mean of 200 and a standard deviation of 16. New production methods have been introduced. The Vice President of Manufacturing would like to investigate whether there's been a change in weekly production for this model. So we're asked, is the mean number of desks produced different from 200 So mean number of desks produced in this sample, right, different from 200 at the 0.01 significance level. So the first step that we're going to do, right, our null hypothesis is that mu is equal to 200 desks. Our alternative hypothesis is that mu is not equal to 200 desks. The second is our level of significance. Well, we're given the level of significance alpha is equal to 0.01. The third is to calculate the test statistic. We're going to use a z statistic. And we're going to take x bar, we're going to minus mu, and we're going to divide it by sigma over square root of n. So for this particular one, right, 200 minus 200, our z statistic is going to just be 0. To make it easy, but also slightly confusing. The fourth step that we have is to formulate a decision rule by first determining the critical values of z. So decision rule, which is really just asking for what's my crit values. And so we're going to go ahead and we're going to go down here and we're going to figure out, okay, since I have a two-tailed test, my alpha is actually going to be divided by 2 because I'm trying to figure out if it falls in this range and if it falls in this range while still having 99% in the center. So in order to do that, I have to have 49.5% here and 49.5% here, so that it adds up to 99% out of the full thing, right, which we can see up here is 100%. And so we find that our critical value for 1% two-tailed test is going to be 2.56. So the decision rule that we can make from this if the computed value of z is not between negative 2.576 and positive 2.576, we're going to reject the null hypothesis. If we find that the z is within that, right, then we're going to fail to reject the null hypothesis. So then we're going to go back to our z statistic. And I actually misspoke. We didn't get all of the information earlier, so this z statistic is not 0. So we figured out what the z statistic is. And then we're given more information in step 5, which is aggravating. So we're told that the mean number of desks produced last year was 203.5. So we're told that x bar is equal to 203.5. We're told that the standard deviation for the population is equal to 16 desks per week. So putting this in, with our mu is equal to 200 and our n is equal to 50, we end up with x is equal to x bar minus mu over standard deviation divided by square root of n, which is equal to 203.5 minus 200 divided by 16 over square root of 50. This whole thing gives me a z value, sorry, not x value, z value of 1.547. So then we can make a decision, right? 1.547 falls within negative 2.576 and positive 2.576, and therefore we don't reject the null hypothesis. And then we can interpret these results in our last step, which says we did not reject the null hypothesis, so we have failed to show that the population mean has changed from 200 per week.